Our speaker today are Saha, software engineer at VMware by Broadcom, and RayanDas, SRE at OneTrust. Orko is a leading Kubernetes release for Tazo extended support. Whereas Ryan is a site reliability engineer who's actively contributes to Rancher and serves in Kubernetes community. So let's give on stage to them. Let's give a round of applause to them. Right? Yeah.
Hi. Hello everyone. Good afternoon and welcome to KCD Kerala. Thank you for coming to this session. Our session is on Prow under the hood CI/CD for Kubernetes development. So as they have already introduced us, I am Arka Saha, working as a software engineer at VMware, which is now acquired by Broadcom. I'm responsible for building, testing, and releasing Kubernetes, as well as maintaining the CI signal for VMware's own product, Tanzu. Over to you.
Hey everyone, I am RayanDas. I'm working as a senior site reliability engineer for OneTrust. I was part of the Kubernetes release team for 1.29, and you can find me contributing in SIG release and SIG CLI. Thank you. So yeah, in this session we are going through these topics, where we will take you through what is Prow and why do we use it, and what type of Prowjobs we have, and delve into the anatomy of the Prowjob and see how you can write your own Prowjob, and finally summing all this up in the key takeaways. So over to you.
Thanks, Ryan. So let's see what Prow is. We have all come across multiple times while contributing to the Kubernetes or any auxiliary projects that there is something called KTS robot, or there is /LGTM. So we have all came across or interacted with Prow somewhere or the other. So what is Prow? Prow is essentially a Kubernetes-based CI system to test Kubernetes on Kubernetes. So that is the main idea of having the Prow. And it comes with features that can be extended, like the GitHub automation that we have. So this is the robot that you might have already seen. And like from here and now, you raise a PR, it comments back. If it's your first PR, it greets you. And it does all the automated stuff like merging and all that. So that's one of the features that Prow comes with, is the GitHub automation. Another is the ChatOps, which is built in. It's like a intuitive mode of interaction where one can ask the KTS CI bot to perform certain action, like /assign will assign some issue to you, /hold will hold that and not allow you to merge it. In this screenshot, we see an example where /honk actually comes up, like the CI bot comes up with a picture of a goose. So things like that we can do with ChatOps. Next comes pluggable feature, which is like test grid. Again, it is very commonly used and very widely used by the release team itself, Kubernetes release team, where it gives you a overall understanding of how the tests are working, whether they are flaky or not, what is the stability of the test, what needs to be fixed, and all that. It gives you an overall view of the entire testing system before a Kubernetes release goes in. Next is configuration as a code. So Prow, the main kind of point of using Prow is because it is so simple. It takes YAMLs as your configuration. So whether it be the Prow infrastructure, whether it be the Prowjobs itself, which you need to write, it is just YAML files that you need to maintain, and it is very easily maintainable and configurable. And Prowjob, as we will come to it, is just like writing another Kubernetes pod spec. So if you want to learn more about Prow and how it works, how the architecture works, and deep dive into each and every component of Prow, these are really great talks that is there. You can go through it, and like you will get all the information that you need to kickstart your development project. So let's come to why we are going for Prow for CI/CD. There are so many CI/CD tools. Why use Prow? So, since it is based out of Kubernetes, there's a platform familiarity. Any cloud native developer will know the problems that comes with something that is running on Kubernetes and the errors that Prow might throw here and now. It will be very easily debuggable and understandable. So there is a platform familiarity. Next is the reliability. So as we know, Kubernetes is reliable, and Prow being created on top of Kubernetes comes with the same reliability features like scalability. There is vertical and horizontal pod scalability, which is very quick. So your CI/CD can accommodate more tests when developers are pushing continuously without throttling. Next is the monitoring. So like we know, Kubernetes itself has a whole suite of plugins for monitoring, and something like Prometheus Grafana that we have a screenshot of. It actually lets you know how much or what capacity your infrastructure, CI/CD infrastructure is running at. This is actually the screenshot of the upstream Prow usage. Next is the workload. So let's say you are just a developer trying to run your tests on Prow, and you are just concerned about that. Prow lets you do that. So Spyglass is something that comes bundled with the Prow. This is the interface that you see. So basically, the job that you have written, you can go and check whether it's running well, what are the logs that is coming out, if there are errors, how to debug it. And it gives you a visual representation of how the job is performing. Next is the multi-cloud. Is basically Prow is not restricted to just one cloud, that is the Google Cloud, how it started off. So right now in upstream, there are many workloads which are being migrated from Google Cloud to Azure. It's an ongoing development process, but it can support multiple clouds all at once. Then we come to the part where there is automation, and Prow provides a lot of automation scopes. One such is something that we discussed a few minutes back, was the GitHub bot. Since Kubernetes is a huge project and there are so many contributors, maintainers, reviewers, it's impossible to keep a track of all the PRs, all the issues that come in. So what this automation does, the GitHub automation bot does, is it alerts the maintainers specific to that issue or that PR, labels those PRs accordingly, and then merges the PR once all the approvals are in place. Next comes to the multi-org, multi-repo thing. So traditional CIs become very specific to a particular repository, particular project or organization, and we need to like design it like that. But Prow, as you can see in the screenshot, there are so many different organizations with different repos inside it. So everything can be clubbed inside in a proper directory format within Prow, and it will run in a consolidated manner, and it will give you that kind of view as well. So you can manage all the projects across organizations in one single place. So coming to Prowjobs, Ryan, please.
Yeah, so let's talk about the types of jobs that you can run on Prow. So there are three main type of jobs, which are pre-submits, post-submits, and periodics. So pre-submits run on a pull request. So whenever someone raise a PR, the pre-submit jobs get kicked off. You can also define that certain pre-submits are required to merge the PR. And periodics. So periodics are just like what they sound. They run periodically, much like cron jobs. Post-submits. So post-submits run on a branch after or after merging a PR. You can define the branch that you want the post-submits to run on, and they will run when new code gets merged into that branch. Now let's talk about how to write a Prowjob. So be it pre-submits, post-submits, or periodic. So this is an anatomy of a Prowjob, and we will cover cover what each and every configuration parameter means. Before we start, on the left-hand side, you'll see certain code blocks are color coded, and the green part is a common type of, common to all type of Prowjob for pre-submits, post-submits, and periodic. And the red one is specific to periodics, and the magenta is only for pre-submits and post-submits, and the finally the orange one is only for pre-submits. So now let's go through the config. So this part specifies all type of Prowjobs, and this part is only for orgs and repos to clone. This specifies the name of the job, and this enables addition of the preset to the job container. And the preset looks like this. Where we add environment variables, volumes, volume mounts inside a job container without having to repeat it in every Prowjob. So this can lie within a Prowjob YAML or config YAML. So this part enables pod utils, which essentially helps to clone the repos using extra refs without worrying about overhead, Git related access or cloning. This specifies to run on every PR or run request, and this means it can run maximum this many job instances concurrently. And this one is here you can mention the pod spec. This is the frequency of the periodic job that will run. This will run if regex condition is met. This specifies whether to skip setting status on GitHub. Context is basically the status context, which is same as job name. And this lists branches to run or skip. So we can't use both of them together. So this is mostly useful when we want to run similar kind of jobs via ChatOps in one shot. So basically, when we comment test rerun, it will run all the Prowjobs matching this command. So now Arko will take you through how to test your Prowjob. So over to you.
Thank you. Thanks, Ryan. So now that you have learned how to write a Prowjob overall, let's see how you can test it. So before even pushing a Prowjob to upstream to run all the tests, it's better that we do it locally, right? So that's one of the things that we will do here in the next few minutes. It's basically there is a capability to run the Prowjob that you have written on a local kind cluster. So basically what it does is essentially it runs those Prowjobs or the workloads that you have written as Prowjobs as pods in a kind cluster. So this particular PJ on kind .sh is present inside the test infra repo itself under config, which you can run with the command of the test name that is there. It will pick it up and it will, if there is no kind cluster available, it will create one and it will run it as a pod, run the Prowjob as a pod. So there are a few configurations that I'm not going to go through because that is something that you can already get it, and also in the interest of time. So this is the link where you can get all that information of initial tweaks that you need to do, but the main and the minimal tweaks that needs to be done is basically changing. So in this case, it's a pre-submit. So like Ryan told previously how to write a Prowjob, we need to mention the org and the repo name. So there usually we tend to write the upstream org and the repo name, but we need to put the forked one so that we can test it on our project itself, whether it is running correctly or not with our commits or the PRs that we are going to make in the future, just to make it run seamlessly. Along with that, we also need to make a few changes. That's like where the Prowjob logs will get outputted and the node logs will get stored. So that needs to be the local path that is to our machine. So that change needs to be there. And once that is there, we will see how we can run it. So give me a minute. So yeah, like I said, it's just config pg1 kind and check go vulnerabilities is the Prowjob that I've written. Now you can see it is running up, like it's creating a kind cluster, and then it will ask for the PR number. If you see at the bottom, I'm not sure if it's completely visible, but yeah. So I just gave the PR number 1, and it is running the Prowjob. If you can see, it's trying to spin up the pod. And yeah, that's how it is. And we will also check that how the logs look like. So we go to the path that we have mentioned in the code itself, like the local path, and then we'll see that, okay, there is a specific folder to that particular Prowjob, and then the job ID, basically the run ID of that particular job. So we can pick up any one of them. So I've run it twice, so that's why it comes 2 times. And if you see, this is how it will look. So what Spyglass does is, you saw all that .json and .txt files, it kind of aggregates it and puts all that information into the UI that we saw previously. Yeah. So now let's come to the key takeaways. So we are towards the end of our session, and let's start summing it up. So the best place to start with the Prowjobs and learning more about it, it's test infra, Kubernetes test infra. It is a warehouse of different kinds of Prowjobs from different organizations, different repos, different projects, and all gets aggregated in that one repository. So we'll find all kinds of usages, different kinds of automations, different ways of publishing image, promoting artifacts, all that you will find it in the same place if you dig in. And also sig-testing is kind of short-handed at this point, and they really encourage new contributors to come up, contribute, improve, and add new jobs to the Prow. And since Prow allows a lot of room for automation, we developers can identify the scopes and leverage Prow in doing the everyday CI/CD process. And this can be done by writing and testing the Prowjobs itself. And since we write cloud native code, we make it cloud ready, it's best that we test it on Kubernetes itself. And that's what Prow is doing. And we can develop with confidence by writing the code, and we can ensure that the code is of quality and it is robust, because Kubernetes does it the same way. Kubernetes does their do their releases based on the CI signal that's coming from Prow. So yeah, if you're writing code, if you're testing it through Prow, you can say that, yeah, my code is of good quality and it's robust. And that's all. That brings us to the end of our session. Thank you everyone for your patience, and we're open to questions.
Any questions? Okay, looks like there are no questions then.
Okay, then I give you 11 minutes back to you.
Okay, everyone, give them a huge round of applause for a great talk, guys.